A limit describes the value that a function approaches as x gets closer and closer a particular value. Limits are one of the fundamental ideas used to understand calculus and continuity. When x approaches a, we observe what value f of x approaches. If the function approaches the same value L from both the left and right sides, we say the limit exists and equals L.
We can approach a from the left or from the right. These are called the left-hand limit and the right-hand limit. The two must be equal for the ordinary limit to exist.
For a simple example, consider x plus 3 as x approaches 2. As x gets closer to 2 from either side, x plus 3 gets closer to 5. Therefore, the limit is 5. A function is continuous at x equals a when three conditions are satisfied. The limit exists, and the limit equals the function value. Visually, the graph has no break at that point. Let us check continuity for f of x equals x squared at x equals 2. The function value is 4, and the limit as x approaches 2 is also 4. Here is an example with a removable discontinuity. The expression simplifies to x plus 1, so the limit as x approaches function is not defined at x equals 1. The whole can be removed finding f of 1 as 2. A jump discontinuity occurs when the left-hand and right-hand limits are different. Since the two limits do not agree, the overall limit does not exist, and the function is discontinuous at that point.
Sometimes a function does not approach a finite number. Instead, its values can increase without bound as x approaches a. We describe this behavior using an infinite limit.
To summarize, a limit tells us what value a function approaches. A limit exists when the left and right approaches agree. A function is continuous when its limit equals its function value. These ideas form the foundation